In college algebra, we started combinations of functions. Right here, we have a problem from the textbook about taxes. There's actually a typo in this picture. This federal thing is supposed to say total. So what we're looking at here is we want to be able to predict or figure out what the federal tax was. So there's two types of tax whenever you have to pay your taxes. There's your total tax, which is a combination of the federal plus the state. So in this example, they say look at the values in the year 2000. So you go all the way to the right. Here's the year 2000 in green on the x-axis. We want this value for state and this value for total. And they want to know what is the federal tax in the year 2000. So you do a tiny bit of algebra, and you know that federal equals total tax minus the state tax, and that's what they did below the picture down there. So the total was $10,500, and the state tax was $3,400. They subtracted, and $7,100 is the federal tax. It's pretty simple when you talk through it like that. The confusing thing is the notation. So we're about to do combinations of functions, and many times they write it like you see typed at the bottom of the screen. So when you see that, t minus s of x, they're just telling you to subtract the two functions. So let's practice it with algebra equations. If we want f plus g of x, this means combine the two functions, add the two functions, by combining like terms. So very simple, or I hope you think it's simple. We write function f plus function g, and you add like terms. I don't see anything other than an x squared for a squared term. So that I like to lead with the biggest exponent. So x squared. I see a 2x, but I don't see another x term, so plus 2x. And then I see a 1 and a negative 4, so that adds up to negative 3. And that's it. Maybe give number 3, part A, a try. Just add the two functions. Hit pause and see if you get the same thing I do. So here's the f function. Here's the g function. Combine like terms. We got an x squared. We have a 4x. And negative 3 and 5 are like terms, so plus 2. And that's it. For part B, they want us to plug in 3 in place of x. So 3 squared plus 4 times 3 plus 2. And we end up with 23. So far, I hope it's very simple. The notation, like I said, is a little confusing, but you just combine the two functions. All right. It does increase in difficulty, because what if we have a square root function and they ask about domain? Domain and square roots, that's kind of tricky. So first off, the f plus g part is very simple, because when I have this function plus this function, there is no math to be done. That's the answer. These are unlike terms, cannot combine. For example, like if you're confused about that, Like if I had square root of x plus square root of x, that would be 2 square roots of x. But if I have square root of x plus square root of x plus 1, those are different. I can't do anything. You're just stuck. If I have square root of 10 plus square root of 10, that's 2 square roots of 10. If I have square root of 11 plus square root of 13, can't do anything. That's just the end. All right? Hopefully that helps. Anything with square roots is always confusing, especially when it asks about the domain. So let's rewind. Back to a few weeks ago, we had a problem like this. So that's I. It's not real. This cannot be graphed on the coordinate plane, on the real coordinate plane. So when they ask about the domain of that square root function that we just found on part A, we have to figure out where it's positive, where the value underneath is positive. So find values where the expression under the radical are positive. So that's the first hard step. You set each one to greater than or equal to 0. So x plus 3 is the first expression under the radical. I force it to be positive. Solve that little thing. I subtract 3 from both sides, and I know that first radical is positive when x is bigger than or equal to negative 3. Check the other one. X minus 2 greater than or equal to 0. Add 2 to both sides. And it's positive when x is bigger than or equal to 2. So that's the first hard part. Now, check values for both square roots. And the one that comes out is true for both is the answer. So, for example, let's change colors. This one here means x greater than or equal to negative 3. This means that negative 2 should work. So if I plug in negative 2 into the first square root, I got negative 2 plus 3, I get a 1. That works out. That checks out. If I plug negative 2 into that second square root, I get negative 4. That doesn't work for both. If I plug in a 3, it gives us a positive for both square roots. So works for both square roots. The domain is that one. That question right there is very difficult when you have two different square roots, much less just one square root. We'll practice that down the road. The other thing that they're going to ask is for the difference, the product, and the quotient. So you do exactly what the word describes: subtract, multiply, and divide. So when you subtract, please use parentheses. I start by just writing the f function minus, and then I put parentheses around g, because all those signs are going to flip. So I end up with 2x minus 1 minus x squared minus x plus 2 and then combine like terms. So I end up with this plus x plus 1. For a product, please even more so use parentheses. And we need to distribute that. We're going to get 6 terms. And then 3 more down here. So go slow. Remember when we multiply with exponents, we add the exponents. Because there's really a 1 right there. All right, so be careful with that. So the first thing we get is 2x cubed plus 2x squared minus 4x. And then let's do the negative one. Negative x squared, negative x plus 2. And then combine like terms. I don't see more than just that 1 cubed. 2x squared minus x squared gives us positive x squared. Negative 4x minus x gives us negative 5x. And then plus 2. For part C, you want to start by writing your fraction. So f goes up top and g on the bottom. And in a situation like this, I need to factor to see if any factors cancel. Because there is a chance that I can reduce that fraction. Up top, I don't see a GCF. I don't see an x squared. I can't factor the top. The bottom, I don't see a GCF, but I do need 2 numbers that multiply to negative 2, but add to positive 1. So that ends up working out pretty nicely. Up top, it stays the same. On the bottom, do your 2 parentheses. And we have an x and an x. 2 numbers that multiply to negative 2, add up to 1. That's a plus 2 and a minus 1. And we end up seeing that we just wasted our time. If that bottom right factor had had a 2 right here, I could have canceled all that. But it didn't. So, no deal. Sorry, we wasted our time with factoring. No factors cancel. So that's always a little annoying when you do work that you didn't have to do. I'll take either fraction. That one's simplified. But if you just left it how I had it factored, that'd be fine too. All right, we'll do the harder stuff, composition of functions tomorrow. See y'all later.